This is the next lecture on capacitors, and this time we want to find the charge on each capacitor when the capacitors are hooked into a circuit with a battery across them. Copy this particular circuit into your notes, and the three key formulas you should be aware of are Q equals CV and the equivalent capacitance formulas. And what you should do is just pause the video and give yourself a moment to think about which capacitors will be positively charged, which plate of the capacitor would be positively charged, which capacitors are in series, and which capacitors are in parallel. And then try to develop a plan of action to find the charge on each capacitor. So this is a good moment to just pause and think. Okay. Now what I'll do is go through how to think about this problem. And the first thing you have to do is reduce this circuit into something simpler. So you have to see that you have two capacitors in parallel right over here. So let's redraw that over here. So the two capacitors in parallel are these. And then you want to find the equivalent capacitance, like so. And then that's easy because the capacitance is just add, so you have an equivalent capacitance of 6 microfarads. Okay, now you go back to the original circuit. You've managed to reduce the two capacitors in parallel to an equivalent capacitance. And then you see that that combination is in series with C3, like this. Okay, so redraw your picture again, and this time what you'll have is the equivalent capacitance of C1 and C2 over here, and then that's in series with C3. So in combination, there's an equivalent capacitance called C123, and then you can find the equivalent capacitance using one of those formulas over here. So ultimately, you will find that the equivalent capacitance is 2 microfarads. And again, don't stick the micro into your calculator too quickly. Try to factor it out like this, and then it's much easier to do the calculations. Once you've figured out the equivalent capacitance C123, go back to your circuit up here. And now what you can see is that there's a 12-volt battery located across C123. So redraw your circuit again in this way, like this. 12 volts across C123, which you now know is 2 microfarads. Now this circuit is very simple, and you can figure out the charge on the capacitor. So what you see is that Q equals the capacitance, C123, times the voltage across the capacitor. But the voltage across the capacitor is 12 volts. So Q equals 2 microfarads times 12 volts, and your answer is 24 microcoulombs. And what that means is that you're going to have a plus 24 microcoulombs over here, and a minus 24 microcoulombs over here. Given that, you now go backwards in terms of your capacitor diagrams, and you start to undo all of those equivalent capacitance types of operations. So the C123 was composed of C12 over here and C3 in series. So now I've drawn them in series, and you know that there were 24 microcoulombs across the equivalent capacitance, which means that for C12, the charge on it was 24 microcoulombs here. And then that means that the right side, the right plate is minus 24 microcoulombs. But because this whole section here is neutral, it means that Q3 is plus 24 microcoulombs. And then the other side of it, other side of C3 is minus 24 microcoulombs. So now you have the charges on each one of those capacitors, and you can now figure out the voltage across each capacitor. So the voltages are labeled V12 and V3. So the equation you have to use is Q3 equals C3V3 and Q12 equals C12V12 over here. So let's plug it in. So let's work on C3 first. So you know that there are 24 microcoulombs across C3. You know the value of C3. That was given to you. So that's 3 microfarads. And then you're trying to find the voltage across the capacitor. So remember, this V3 means the potential difference between the two plates of the capacitor. So it's really a delta voltage, but we just write that as V3. Okay, this tells you that V3 equals 8 volts. I'll write it as VOLTS. Okay, now once you know that, you can figure out the voltage across C12, because you know that you've got to have 12 volts between the left side of the capacitor system and the right side of the capacitor system. So that means that 12 volts is the sum of V12 and V3. So if we know that V3 is 8 volts, then we can figure out what V12 is, which is 4 volts. Okay, so with that, you can insert it into the equation over here, and you now know that Q12 is 24 microcoulombs, C12 is 6 microfarads, and the voltage is 4 volts. Okay, you're still not done yet, because in the original problem, the C12 was a combination of 2 parallel capacitors. So you go back and break open that C12 into C1 and C2. So that's shown over here. And then you know that there's a certain amount of charge on each capacitor, so I've labeled them Q1 and Q2, and there's a certain voltage across the 2 capacitors. And you can see that in this problem, V1 has to equal V2. You also know the voltage across the 2 capacitors, because that should equal V12, like this. And V12 is 4 volts. So now what you can do is insert this information into the equations above. So Q1 equals C1, which is 2 microfarads, times by V1, which is 4 volts, giving you 8 microcoulombs. And then we can do the same for Q2. Q2 equals 4 microfarads times by 4 volts, or 16 microcoulombs. So in the end, when you look at the whole system over here, let's go back up, you know the following. You know that C1 has 8 microcoulombs over here, minus 8 microcoulombs here. C2 has 16 microcoulombs here, and minus 16 here. And then C3 has 24 microcoulombs here, and minus 24 microcoulombs here. And all this checks out because the sum of these two and this have to equal 0. So now we know the charge on all of the capacitors. That's the end of this video.